In this session, we will learn about Euclid's division algorithm. First of all, let me clear that you are learning this algorithm since childhood. There is nothing new in it. You know how to find the HCF, means highest common factor of two or more numbers. Here we have 32, 24 and 60. This is the prime factorization of 32. And the prime factorization of 24 is this. And also prime factorization of 60 is this. Here 2 is common in all these three numbers. There is another 2 common in all these three numbers. So what is its HCF? It is 2 into 2, which is 4. And also these are the factors of 32. And these are the factors of 24. And these are the factors of 60. 1 is common in all these three factors. In fact, 1 is always a factor of every number. And also 2 is a common factor of these three numbers. And 4 is also a factor. So all of these three numbers are common factors of 32, 24 and 60. It is also called common divisor. But you can see 4 is the largest common factor between these three factors. That's why it is called HCF, highest common factor. 4 is also called greatest common divisor, that is GCD. So it was all about HCF. You already know it. But there is a problem. You are not a kid. You are a 10th standard student. So you deserve something which is more complicated and deep to understand. There are many hidden features in this HCF that you still don't know. And we will learn it in Euclid's division algorithm. To understand Euclid's division algorithm, we need to know about a theorem. Let's understand this theorem. A and B are positive integers such that A is equal to BQ plus R. So we will take two integers. Let A is equal to 32 and B is 24. In last session, we learned about Euclid's division lemma. So we get A is equal to BQ plus R, where R is greater than or equal to 0 and smaller than B. So we can write 32 is equal to 24 into 1 plus 8. Also we can write it in division form. Now in this given theorem, we have been told to take common divisors of A and B. 4 is a common divisor of 32 and 24. Also 1 and 2 are the common factors of 32 and 24. Also 8 is a common factor of A and B. Now in the given theorem, it is said that every common divisor of A and B is the common divisor of B and R. Let's see what is the common divisor of B and R. We have B is equal to 24 and R is equal to 8, where R is remainder. So we have taken the prime factorization of 24 and 8. In both 24 and 8, we have 2 into 2 into 2 common. That means common factors of 24 and 8 are 1, 2, 4 and 8. And hence HCF is 8. That means common divisors of A and B are the common divisors of B and R. In the theorem, we have a word vice versa. That means every common divisor of 24 and 8 is also the common divisor of 32 and 24. That means we saw that every common divisor of A and B is the common divisor of B and R. That means common divisors of 24 and 32 are same to the divisors of 24 and 8. Let's take another example to understand this. We have divided 56 by 42. And this is the prime factorization of 42 and 56. Now 2 and 7 are common, so HCF is 14. And we have to take prime factors of 42 and 14. In this case, we also have 2 into 7, which is equal to 14. That means HCF is same. Also we have divided 70 by 25. And their HCF is 5. And the HCF of 25 and 20 is also 5, and vice versa. I think this concept is clear now. This was a hidden feature that you didn't know yet, but what is the purpose behind knowing this theorem? Let's see. We have 15 and 36. By dividing 36 by 15, we get quotient 2 and remainder 6. We can also write this division as an equation. Now let's visualize what is happening here. We have 36 red balls and also we have 15 green balls. So green balls cover red balls 2 times and leaves 6 balls uncovered. That means now red balls are divided into 2 parts and each part has 15 balls. Green balls can be put as it is. Now we have a set of 15 balls in each group. Also we had 6 balls left, so we put it as remaining. Now look at our division. It is exactly same as we arranged our green and red balls. We divided 36 by 15. Now we will divide 15 by 6. And we get 2 as quotient and 3 as remainder. Also we can write it as an equation. Now let's visualize it. So we will work with 15 green balls and 6 red balls. 6 red balls can cover green balls 2 times and leaves 3 green balls uncovered. That means we have 2 groups of green balls and each group contains 6 balls. 6 red balls can be put as it is, and 3 green balls are left, so we will put it as remainder. We can arrange red balls. Now it feels more comfortable. Now we see there are 3 groups of balls and each group has 6 balls. But still we have a group of 3 green balls which is not suitable with these 3 groups. Let's look at our division. Again we will repeat our division process. This time 6 will be divided by 3. And at this step we get remainder as 0. We can also write it as an equation. At this moment remainder is 0. So 3 is the HCF of 15 and 36. So here we found that HCF is 3. But I am not able to understand one thing. Why HCF is 3? This could have been 6 too. Why we are taking this special number 3 as divisor? That means HCF. Let's understand this. Even most teachers are not aware of this. So forget about the fact that children might be aware of it. Here 15 is B and 36 is A. 6 is R means remainder. That means we have divided 36 by 15 and got remainder 6. The fact is that common divisor of 15 and 36 will also be the common divisor of 6 and 15. We have already understood this fact in a theorem, but in this position we don't know what HCF is. That's why we will find the common factor of 6 and 15. At this moment 15 will be A and 6 will be B. And after dividing 15 by 6, we get remainder R3. Note that we still don't know HCF. So again we will use that theorem. So common factors of 6 and 15 will also be the common factors of 3 and 6. That means this time we will find the common factor of 3 and 6. Means now 6 is A and 3 is B. And after division we get 0 as remainder. Now again we will apply that theorem on 3 and 6. That means common factors of 3 and 6 will also be the common factors of 3 and 0. But here remainder is 0 now. That means we can get the common factor of 3 and 6. But what will be the common factor of 3 and 0? Now be careful. 0 means nothing. That means we don't have second number. We have only 3. And we know that to take anything common, we need at least 2 objects or numbers. What I mean to say is that, let's assume we have a group in which there are many colored balls, and also we have another group of balls with different colors. If I ask you what is common in these 2 groups, you will say yellow ball is common. That means yellow ball is a common factor of these groups. But what if we remove one group? And now I ask you what is common in these balls? Then what will be your answer? You will say nothing. We have only one group. And to take anything common, we need at least 2 groups. That means in this condition, we will get only the common factors of 3 and 6. That means we don't need to continue this division further. Now the common factor of 3 and 6 will be 3, and this is also the highest common factor. Because here 3 is dividing 3 completely in one shot and leaving remainder 0. And this happens only when we take greatest common divisor. You can also see 3 is dividing 6. It is also dividing 15 and also dividing 36. That's the reason why 3 is the highest common factor or HCF. Don't worry, if you still have some doubts, we will clear it by 3D animations very well. Now let's see what just happened. Here 3 green balls can cover red balls 2 times completely and we don't get any remaining balls. That means we have 2 groups of red balls containing 3 balls in each and 1 group of green balls containing 3 balls. And there are no red balls left as remainder. So what it tells? It tells we can arrange red balls in groups in such a way that each group contains 3 balls. Also we will have green balls group and each group will have 3 balls. Now you can see we have arranged every green and red balls in such a way that all of these are assembled in only 3 columns. No green or red balls are left outside. You must be confused a little bit, but don't worry. We will take another example to understand this concept completely. We have 32, 24 and 60 balls. Let's put them into groups of 2. So we will get 2 columns and also it is looking very long. This time we will put them into groups of 3. But this is not a complete group because here we have 2 pieces. One ball is missing. We will understand it later why this is happening. This time we will put them into groups of 4. And we get 4 completely fulfilled columns. Again we will put them into groups of 8. you can see one group is not completely filled. 4 balls are missing. Now let's understand what we did here. This is the example we had taken in the beginning. In 32, 24 and 60, the common factors are 1, 2 and 4 and HCF is 4. In first case, we have 2 balls in each. In second case, we have 3 balls in each and 1 ball is needed to fulfill the blank space. So here you can see 3 is not a common factor. That means yellow balls cannot be arranged into groups of 3. Only sky blue balls and pink balls can be arranged into groups of 3. In third case, we have taken the groups of 4. And in fourth case, we have the groups of 8. Here you can see 4 is a common factor also. It is the highest common factor. But 8 is not in the list of common factors. That's why 8 has 4 missing balls. And also you can see 1 is a common factor of 32, 24 and 60. That means we can also put these balls in groups of 1. Now you can see 1 is a common factor, so we have a single column. Also 2 is a common factor, so we have 2 columns. But 3 is not a common factor. Also 4 is a common factor, so it has 4 columns. Also 8 is not a common factor. Now you can see 4 is the HCF. The format which have 8 balls in each group is occupying less space. But there is a defect in it. 4 balls are missing. That means if 4 balls are added to it somehow, then it will become a valid format. That means for now, the group which have 4 balls in each is taking less space. Because it is the greatest valid form, that's the reason why 4 is called highest common factor. Here you can also see 4 is the greatest common factor. But what if we replace 60 by 64? That means in this condition, 8 will be a factor. Now you can see 8 is common in all these 3 factors and it is now the greatest common factor. Let's see it by visuals. Now we have added 4 more balls in it and now this is a complete group. Now let's understand what are the benefits of finding highest common factor, or we can also say it greatest common divisor. Does it have any worth in real life or not? 3 is not in the group of common factors, so we will remove it from here. Here we have taken a grass board. You can also consider it as a football ground. We have 24, 32 and 64 balls. By adding them we get 120. Let's bring grass board here. If we assume that one ball is covering 1 square unit area, then 120 balls will cover 120 square unit area. This means no matter how we arrange these balls, they will always cover an area of 120 square unit. That means we can arrange these balls in a single row, double rows or 4 rows or 8 rows. They will always cover 120 square unit area. We don't care about area, we are finding something else. If we arrange all the balls in single row and put them on the grass board, they will cover the minimum area of the board. Remaining balls will stay outside of the board. If we put them in groups of 2, this time they will cover slightly more area than last one. But still greater part of the balls will stay outside of the grass board. If we take groups of 4, then balls will cover half of the grass board, but still half balls are outside. When we take the groups of 8, then we find that balls have covered the complete grass board. So what did you learn from it? HCF explains how to arrange things in a minimum space so that they fit perfectly. Note that here we are not concerned with area. We have simply designed our space to accommodate as many balls as possible in the least amount of space. That means we will fit the balls in 8 rows so that less space will be used. You have seen how students stand in rows during prayer. You have also seen army parade. They make lines to stand in such a way that they take less space. If they decrease the number of lines, then they will go outside the ground on roads. That's why here HCF is used so that army will stay in field in less space. You must have seen sweets in rows and columns at sweet shop. In all these places we use HCF. Now let's make a proper statement of Euclid's division algorithm that defines it. Now you know enough about Euclid's division algorithm. You don't need to write because you have already seen it visually. You can write this statement according to your own understanding in your own way. Euclid's division algorithm is a process to find the HCF of two numbers using long division method repeatedly. To understand more about it, we will first understand what algorithm is. The word algorithm is derived from the name of Persian mathematician Al-Khwarizmi. Algorithm is a series of well-defined steps based on previous steps and repeated till the desired result is obtained. You can write anything that hits your mind, but the summary of your statement must be same to this statement. Here we have divided 36 by 15 and got remainder 6. Again next time we repeated this long division process and this time we divided 15 by 6. We also repeated this process third time and this time we got our desired result. That means we found our HCF. That was all about Euclid's division algorithm. Let's end this topic here. See you soon in next session.